Hello everybody. In this video we are going to be looking at the solutions to the college prep electromagnetic induction homework problems 11 through 15. Let's take a look at problem 11. We have the primary coil of a transformer has 150 turns. It is connected to a 120 volt power source. Calculate the number of turns on the secondary coil needed to supply the following voltages. So we are given a couple of things to start with. We are given the number of turns on the primary coil of the transformer, which is 150 turns. We are given the primary or input voltage of the transformer, which is 120 volts. And we are asked to calculate the number of turns on the secondary coil needed to supply certain voltages. And the first voltage that they ask us to use is 625 volts. So that's the number of volts on the secondary coil. And we want to find the number of turns on the secondary coil. So I know for transformers, I want to use the following equation. The ratio of the secondary voltage to the primary voltage is equal to the ratio of the number of turns on the secondary coil to the number of turns on the primary coil. Remember, we could read these as ratios, and altogether this is just a proportionality, so we could just treat this proportionally. If I want to solve for, let me just do a couple of erasers here. If I want to solve for the number of turns on the secondary coil, I know that that is going to equal the the voltage on the secondary coil times the number of turns on the primary coil divided by the voltage of the primary coil. And I could get that by doing a simple cross multiplication, probably the easiest way to solve these problems. When I do that, I'm going to have NS times VP is going to equal VS times NP. And then when I have that, I'm going to divide both sides by VP, and then I'm going to have this equation right here. Now I just need to plug my known values into the equation, and when I do that, I'm going to get 780 turns, or 780 turns if you care about significant figures. The second voltage that they want us to use is 35 volts. So remember, that is the voltage coming off of the secondary coil, or the output voltage. And once again, they want us to find the number of turns on the secondary coil. So again, we're going to use the same formula we used in the previous part. We know that the ratio of the secondary voltage to the primary voltage is equal to the ratio of the number of turns on the secondary coil to the number of turns on the primary coil. Solving this by cross multiplying once again. So again, we're just going to cross multiply. We'll get the same formula that we got before. NS equals VS times NP divided by VP. This time, plugging our known values into this equation is going to give us the number of turns on the secondary coil of 150 turns. Part C of problem 11 is asking us to use 6 volts as our voltage off of the secondary coil. So 6 volts as our output voltage. Once again, we are finding the number of turns on the secondary coil. We are going to use the same formula we've been using. The ratio of the secondary voltage to the primary voltage is equal to the ratio between, the ratio of the number of turns on the secondary coil to the number of turns on the primary coil. Once again, solving that for the number of turns on the secondary coil by cross multiplying. We are going to have NS equals VS times NP divided by VP. And once we plug in our known values to that equation, we are going to get 7.5 turns on our secondary coil. On to problem 12. A step-up transformer has 80 turns on its primary coil and 1200 turns on its secondary coil. The primary circuit is supplied with an alternating current at 120 volts. And they want us to find what voltage is being applied across the secondary circuit. We're given the number of turns on the primary coil, which is 80 turns, the number of turns on the secondary coil, which is 1200 turns. We are given the primary or input voltage, 120 volts, and we're being asked to find the secondary or output voltage of the transformer. Once again, starting with our transformer formula, the ratio of the secondary voltage to the primary voltage is equal to the ratio of the secondary number of turns to the primary number of turns. This time we are still cross multiplying, so we are still cross multiplying, but now we are going to solve for the secondary voltage. And when I do that, I am going to have Vs is going to equal Vp times Ns divided by Np. Plug my known values into that, and I'm going to get an output voltage of 1800 volts. Part B of problem 12 tells us that the current in the secondary circuit is 2 amps. What is the current in the primary circuit? So they give us the output current of 2 amps, or the current coming off of the secondary coil, and they're asking us to find the input current, or the current going into the primary coil. Because we're dealing with current now, we're going to use a different equation that's going to look at the ratio of the secondary current to the primary current, which is going to equal the ratio between the primary number of turns and the secondary number of turns. One quick thing to note here before we kind of get into rearranging this and doing out the math is that we have the primary number of turns in my numerator here and the secondary number of turns in the denominator. My pen's acting a little bit funny. Sorry about that. That's the reverse of what it was like for the ratio for the voltage. For the voltage, we had the secondary voltage over the primary voltage, just like here we have the secondary current over the primary current. But now we have the primary number of turns over the secondary number of turns. So the current is inversely proportional to the number of turns on the transformer. Whereas with voltage, there's a direct proportionality between the number of turns and the voltage. So just be careful of that. I'm going to do this the same way I was doing the other problems, by cross multiplying. And I know that when I cross multiply and solve for the primary current, I'm going to have the primary current is equal to the secondary current times the secondary number of coils divided by the primary number of coils, right there. And when I plug my known values into that equation, I am going to get a secondary current of, I'm sorry, I'm going to the primary current. I'm going to have a primary current of 30 amps. One other thing I do want to point out, remember that my primary number of coils, so my primary number of coils is 80. My secondary number of coils is 1200. So because there are more coils on the secondary coil than there are on the primary coil, this is going to be a step-up transformer, which means we are increasing the voltage. But now on the step-up transformer, even though I'm increasing the number of turns on the coils, and my voltage would be increased, as we saw in the previous problem, now my current is going down. So my primary current is 30 amps, and my secondary current, which was given, is 2 amps. That should be an A there, sorry. Right. And the last thing I want to point out before we move on is note that my secondary current is decreased by a factor of 15. So it's 15 times less than the primary or input current. And notice that my secondary number of coils is 15 times the primary number of coils. So that's where the proportionality comes in. So just keeping that in mind, that these are just simple proportionalities. Part C of problem 12 asks, what are the power input and output of the transformer? To find the power going into the primary coil, we have to use the current and the voltage going into the primary coil. So my primary power is going to equal my primary current times my primary voltage. My primary current was 30 amps and my primary voltage was 120 volts. When I multiply them together, I'm going to have a primary power of 3600 watts. For my secondary power, or the power exiting the transformer, I have to multiply my secondary current times my secondary voltage. My secondary current was 2 amps and my secondary voltage was 1800 volts. When I multiply those two together, I also get 3600 watts. And that's one of the key really important things to understand about transformers, is that this value, the power, is going to remain the same, even though we are changing the voltage and the current going into and out of the transformer. The amount of power going into the transformer has to equal the amount of power leaving the transformer. So the power should remain constant going into and going out of the transformer. Problem 13. The power supply in a laptop computer requires an effective voltage of 9.0 volts from a 120 volt line. So my secondary voltage, or the voltage coming out of the transformer, is going to be 9 volts. The primary voltage, or the voltage going into the transformer, is 120 volts. The first part asks, if the primary coil has 475 turns, how many does the secondary coil have? So the number of turns of my primary coil is 475. We are being asked to find the number of turns on the secondary coil. We go back to our formula for transformers and for voltage. So the ratio between the secondary voltage and the primary voltage is equal to the ratio between the number of turns on the secondary coil to the number of turns on the primary coil. Once again, we cross multiply and solve for the number of turns on the secondary coil. When we do that, we end up with NS equals VS times NP divided by VP. Plugging in my known values for that, I am going to get the number of turns on the secondary coil is equal to 36 turns. Part B asks, a 125 milliamp current is in the computer. What current is in the primary circuit? We are given the secondary current, or the current leaving the transformer, 125 milliamps, which I do need to convert to amps, so that's going to be 0.125 amps. And I'm being asked to find the current going into the primary coil. And once again, I'm dealing with current, and from the previous part of the problem, I know the number of turns on the primary and the secondary coil, so I can use that information to find the current going into the primary coil. Once again, I'm just going to cross multiply and solve for the primary current. When I do that, I'm going to have the primary current is equal to the secondary current times the number of turns on the secondary coil divided by the number of turns on the primary coil. I plug my values into that equation, and I'm going to have 0.0095 amps, which would round to or convert to 9.5 milliamps. On to problem 14. A hairdryer manufactured for use in the United States uses 10 amps at 120 volts. It is used with a transformer in England where the line voltage is 240 volts. We are given the current in the primary circuit is 10 amps and the voltage in the primary circuit, which is 120 volts. I know that the voltage in the secondary circuit is 240 volts. And the first thing that they're asking us to find is what should be the ratio of the turns of the transformer. So I'm really just looking for the ratio of the set number of turns in the secondary coil to the number of turns on the primary coil. And remember, fractions are just ratios and proportions. So to do that, I am going to use my equation. I know that the ratio between the secondary voltage to the primary voltage is equal to the ratio between the number of turns on the secondary coil to the number of turns on the primary coil. I know that the number of turns on the secondary coil, or I'm sorry, the voltage on the secondary coil is 240 volts. The voltage in the primary coil is 120 volts. When I reduce that down, I am going to get a ratio of 2/1 or 2:1. And because this is a ratio, there are no units. It is dimensionless. And if we look back at our fraction here, I know my volts here are going to cancel out with one another, and that leaves me with no units, which is what I want for a ratio. Part B asks, what current will the hairdryer now draw? And remember, we were given the current going into the primary coil of the transformer, which was 10 amps. Now we're looking for the current coming out of the secondary coil, or the output current. We are going to use our formula for current. Sorry, here, let me just make sure my pen is working. There we go. So we're going to use this formula for the current, looking at the ratio between the current and the number of turns. Again, cross multiplying and solving for the secondary current. I'm going to get the secondary current equals the primary current times the primary number of coils divided by the secondary number of coils. And I know that it's a 2:1 ratio to my primary to secondary coils. So for my primary coils, I'm going to put 1 turn. For my secondary coils, I'm going to put 2 turns. And when I do that math, I'm going to get a secondary current of 5 amps, which makes sense. A couple of things I want to point out here. Note that when we did the primary voltage and the secondary voltage is double the primary voltage. And note that my primary current is 10 amps, my secondary current is 5 amps. It's half, because remember, the voltage is directly proportional to the number of turns, and the current is inversely proportional to the number of turns. So because my voltage doubled, my current needs to be cut in half, or reduced by 50%. The other thing I want to point out here is that we used 1 turn for the primary coil and 2 turns for the secondary coil. We don't know how many turns are actually on the transformer, and that's not necessarily important. What's important is that 2:1 ratio. That's what needs to be maintained. We could have as many turns on the primary coil and the secondary coil as we want, as long as that 2:1 ratio is maintained. I could have 5 turns on the primary and 10 turns on the secondary. I could have 35 turns on the primary, 70 on the secondary. I could have 4,000 turns on the primary coil and 8,000 turns on the secondary coil. Doesn't matter the actual number of turns on the coils, as long as that 2:1 ratio is maintained. It's the ratio that's important. Problem 15. A 150 watt transformer has an input voltage of 9.0 volts and an output current of 5.0 amps. So I know that the power going into and coming out of the transformer is 150 watts. I know the voltage going into the primary coil is 9 volts, and the current leaving the secondary coil is 5 amps. First thing I want to know is this a step up or step down transformer? Because I know that the power is the same going into and coming out of the transformer, I know that the power going into my primary coil is 150 watts. The power coming out of my secondary coil is 150 watts as well. So because I know the output power and I know my output current, I can calculate my output voltage, or the voltage coming out of the secondary coil. So to do that, I know that I use P equals IV. I want to solve that for the voltage on the secondary coil. So that's going to equal the power divided by the current of the secondary coil. And 150 watts divided by 5 amps is going to give me 30 volts. So my primary voltage is 9 volts. My secondary voltage is 30 volts. Because my secondary voltage is greater than the primary voltage, this is a step up transformer. We are stepping the voltage up from 9 volts to 30 volts. We're increasing the voltage from my primary to secondary coil, which means that it is a step-up transformer. Part B asks, what is the ratio of the output voltage to the input voltage? So I know that the ratio of the output voltage to the input voltage is just going to be this fraction here, right? The voltage on the secondary coil divided by the voltage on the primary coil. The voltage on the secondary coil is 30 volts. The voltage on the primary coil is 9 volts. Once again, my units will cancel out here, and I can reduce this down to 10 over 3. So my ratio of the output voltage to the input voltage is going to be 10 to 3.